we're going to take the information we just found from the special right triangles and these key angles, these special angles, and we're going to try to find the other points around that circle based off of those current points, current values. I want you to take a second and get with your row partners and think about that. How are we going to get the points on the other parts of the circle? And I'll give you a little bit of a hint to get there. If you haven't, say you're finding this point right here. You can draw a triangle in there as well. And that will help you generate where that point is right there. Okay, so right now, get with your row partners. I want you to have the conversation about how to find the ordered pair for that point right there. Okay, if you're kind of asking the question, why are we even doing all these points? We're going to answer that in a second. Okay, and we're going to use them in a second. But right now, with your row partner, figure out how we get that point and what that's supposed to be. After you do that, get this point, get that point, and then get all the other points around the circle. Okay? If you figure out how to get this one right there, you then can figure out how to get the rest of them based on what we've already done. Okay? So get with your row partner and have that conversation. So this point right here correlates to that triangle, but kind of the reverse, right? Where this is still squared 3 over 2. That's 1/2, which would make this ordered pair. We went to the left, squared 3 over 2. Whatever that is as a decimal. So to the left, squared 3 over 2 is negative squared 3 over 2, comma, and then we went up 1/2. Right? And then we can just notice, you'll notice that the x-coordinate is just negative. Then this corresponding point on quadrant 1. Also remember, that's in quadrant 2 on our Cartesian grid. The x-coordinate in quadrant 2 is always negative, whereas the y-coordinate is always positive, okay, in quadrant 2. So all those x's from quadrant 1, from those points on quadrant 1, all those x's are just going to be negative, and they're going to match across the rest of it. Then you can just keep running with that to get the rest of them. In quadrant 3, x and y are both negative, right? In quadrant 3. In quadrant 4, just y is negative. And so you can take all the points that are in quadrant 1 and you can apply that to the different quadrants, right? Where in quadrant 2 it would be a negative and a positive. Quadrant 3 it would be a negative and a negative. And in quadrant 4 it would be a positive and a negative. If that makes sense. I want you to find the sine, cosine, and tangent of pi over 6. Okay, based off of this triangle. We know at pi over 6, that triangle fit right in here. Okay, that is also this triangle, because that's a pi over 6 angle. Hopefully that makes sense to you guys. So, find sine pi over 6, cosine pi over 6, tangent pi over 6. And I actually want you to find that for all three of these triangles. Sine of pi over 3, cosine pi over 3, tangent pi over 3. I don't want you to give me a decimal. You shouldn't be having to use decimals, and you certainly shouldn't be needing to use your calculator at all. Okay? And same with this guy. After you look up here and grab them, okay, I want you to find the pattern. This is a key concept. This is a key step that we're talking about. There is a reason, there is a correlation between the sine of pi over 6 and what's represented in the unit circle. And this is one of the reasons for the questions that you guys had asked earlier. Okay, that sine of pi over 6 of 1/2 relates to the stuff we had previously written in the unit circle. Same with the cosine, same with the tangent. Okay, and you can talk with your row partners on this, but match the sine with something that we just did. Match the cosine with something we just did. And then if you get those two, then go to the tangent and match that again with something that we just did. Okay? Go ahead and take a few minutes to do that. This is kind of a key piece in the puzzle that we're working with right here. You'll notice, guys, that this number right there in terms of 30 is right there. You'll also notice that this number right there is right there. And if you keep going with that on the pi over 3, that number right there is right there. That number right there is right there. And I think that makes it a little bit more clear. But the sine of the angle we're talking about that we're evaluating, we affectionately refer to that as theta. The sine of theta is actually the y-coordinate of the point. Okay? The cosine of theta is the x-coordinate of the point. And you know what? That's in alphabetical order, by the way. So that actually, when you generate your unit circle, I want you to write that part of it, just so you remember. If you caught that, you then might catch that, might have caught that tangent is going to be the sine over the cosine. The sine over the cosine. And that's consistent as well. Okay, with all three of them. That makes sense? So we can write that, or the y over the x. Tangent theta equals sine theta over cosine theta, or tangent of theta equals y over x. Now, I know things just got crazy if you didn't catch those yourself when you were thinking about it. Okay? Because we made a lot of connections, we found a lot of patterns in this, which is personally, as a math teacher, why I think it's cool. But okay, so we went through the long process of creating it and generating it. Okay, but the purpose of that is so that we can use it to answer some questions. So now down at the bottom of your piece of paper on the back, I want you to find what the sine of 5 pi over 6 is. What's the sine of 5 pi over 6 is the question. Remember, sine is y. So you can go back to the unit circle. 5 pi over 6, find that. Sine of 5 pi over 6, which is right there, is going to be 1/2 for the y. That makes sense? How about this one? Sine of pi over 2. What is sine of pi over 2? Or you know what? We can make it, let's make cosine of sine over 2. Cosine of pi over 2. Go to the unit circle. Cosine, pi over 2. Find pi over 2. Unit circle. Pi over 2 is the 90. Cosine is the x. 0. 0. Okay? Why are we doing this? So you can find exact values now for these common angles. Okay, rather than approximations. Because ultimately, if you're applying this knowledge in like legitimate real-world applications, you need to use as exact values as possible so that if you're building a bridge, the bridge doesn't fall down. There you go. There's your explanation. That's when you could use it if you're building a bridge. I don't know. You guys remember what your homework is? Your homework. Make one unit circle. Try to do it from memory. Try to generate it. When you get stuck, consult the video. Consult the video. Don't consult your notes, because your notes aren't going to tell you how to get there. Your notes are just going to tell you what it is. It's not going to tell you how it goes and how it's formulated. The videos will. Consult the video, not your notes. One assignment. Pretty simple, right? That was a joke. Have a good day.